In the previous part, we have seen that every ASP.NET Core project has the program.cs file, and that class, or I should say in fact that file, has a very specific task in the lifecycle of an ASP.NET Core project. Let us look at its function. ASP.NET Core 6 applications start and run like a console application. This may sound a bit weird, but yes, each ASP.NET Core application is in fact a console application, and therefore it contains a main function that will execute. Now with C# 10, which is used in .NET 6, Microsoft is pushing the use of top-level statements. Using these, we can, in the program class, in fact omit the class declaration and the static void main method altogether. We will see an example in the next slide. All code that we write in this file will be part of the main method that gets generated upon compilation. If you want, you can still include the main method and the program class, but they aren't required anymore. In any case, the code we will write inside of the program will run when the ASP.NET Core application starts. Now, what code are we going to write in here then? Well, great question. The answer, code to start the server, so to listen for incoming requests, as well as code to configure the application. Start the server inside of the ASP.NET Core application? Did I hear that correctly? Indeed. Each ASP.NET Core application by default will host its own web server called Kestrel. Let's take a look at the code for the program.cs file. Here is the default program that was generated when we executed the empty template. This is the complete generated file, and as you can see, there's no program class nor a static void main. This file is using these top-level statements I just mentioned. Now what is in the code? Let us step through that. First, web application.createBuilder is executed, and that is assigned to the local variable builder. CreateBuilder does some basic setup of the ASP.NET Core platform based on quite a few defaults and conventions. Amongst others, CreateBuilder will set up that web server I just mentioned, Kestrel. Kestrel is a built-in cross-platform server that will actually run as part of your application, and it will handle the requests. Typically, Kestrel is placed behind a real web server like IIS, and that configuration is also done here as part of the CreateBuilder method. Also, the content root, so the place where to find the executable code, is also configured with a default when we call CreateBuilder. And also through CreateBuilder, configuration information is read from a file called appsettings.json, the file we already encountered too. So it's doing this all based on convention. It'll look for a file with a particular name. In short, CreateBuilder does a lot of setup of the application, and if we don't need to change these defaults, we can just leave things as is. And in many applications, that'll do just fine. Builder, so the result, can be used to access the services collection, which we'll use very soon, to register other services. We'll talk more about services in a minute. They are a very important concept. Then we will call build on this, and that is basically the final step of this initialization. The resulting app is then of type web application, and that is used to set up the middleware components and the middleware pipeline. Mapget is in fact a middleware component, but more on these soon. Finally, we'll call run on the application variable, and that will make our application start listening for incoming requests. Now, this may all seem a bit confusing, and I agree. Even for an empty application, all this code seems a bit daunting. Most of this is generated. We can just add our code in a few places in this file, as we'll see in the next part. Now, before we look further at the configuration of the application, I want to spend a minute on Kestrel. Before ASP.NET Core, a plain ASP.NET application required the use of IIS in order to run the application. Now, IIS is a Windows thing, it's the Windows server, and since ASP.NET Core is cross-platform, this combo doesn't work anymore. That led to the creation of Kestrel, a cross-platform server which is really fast, by the way. Typically, all of our ASP.NET Core applications will run on Kestrel. In fact, like I already mentioned, ASP.NET Core applications are console applications, and they host themselves the Kestrel server. You could directly let Kestrel also host your site on the internet. But although this works, most often we'll put a reverse proxy in between. That'll receive the request and hand it off to the actual server, which is Kestrel in our case. In this approach, the reverse proxy is then connected to the internet and Kestrel is only connected to the reverse proxy. In terms of security, that helps greatly. Another important benefit we get this way is that the server itself is now cross-platform and can run behind different reverse proxies on different operating systems in the exact same way. Our application is, in other words, in fact decoupled entirely from the operating system. Now finally, IIS or Apache are much better equipped to fight threats as servers connected to the web. Kestrel remains lightweight and doesn't have to bother with all these extra measures. So yes, running the app on its own lightweight server has a lot of benefits. Kestrel will also be the part within the chain of execution that creates the HTTP context that we'll use further in our application. The HTTP context contains all relevant information of the incoming request received by the server. I will talk later about the HTTP context. Okay, now that we know a bit more about the behind the scenes, let's get back on track and look in more detail at the program.cs, which as said has a very important role in the application. I've mentioned before that we will be doing two main important tasks in the program.cs. We will register services and we will set up the middleware and the middleware pipeline. Since these are both so important, let us look at them in more depth. So first, we can do service registration. Now, what are services? Well, in fact, all classes which we can use throughout our application are referred to as services. This can be, for example, a class that does the logging, a repository, and, well, so much more. Creating small, standalone classes that perform a single task is a good practice, and it's what Microsoft is trying to push here. In fact, ASP.NET Core itself is constructed this way. A lot of the functionalities we can use in our applications are exposed as services too, and we can thus pick only those we'll need in our application. It's a more modular approach. Now, creating all these classes is one thing. We also need to instantiate them. And that's where the service registration comes in handy. Let me explain. Say that we have a class called aController and it will need to do some logging. We have wrapped the logging functionality in a class, a service called Logger Service. That service knows how to do logging, and all classes that now want to log something can create a Logger Service instance and let it do the logging. That is a good way of working. However, this creates a tight link between a controller and the Logger Service. Now, I don't know about you, but when I hear that tight coupling is created, I start getting a bit nervous. Secondly, another problem is that a controller now has the responsibility to instantiate the Logger Service. And next to the Logger Service, the class may want to do data access, and that functionality is available in the data access service. And perhaps it also wants to read a file, and that is available through the file service class. I hope you see where I'm going here. When I want to create a new instance of the aController class, I will be responsible for creating all these other instances. That can get quite heavy. A better approach here is using dependency injection and interfaces. First, instead of directly letting aController work with the Logger Service, we'll introduce an interface, iLogger Service, and we'll use that from aController. Now, that only solves half of the problem. What we want is having a third party create the instances of these services and pass that on to aController. This is dependency injection. We'll have our dependencies, the instances of the services we need, injected into the class at hand. Typically, we'll do this using a container, a dependency injection container, or short, a DI container. We will register all services, often with their interface with this container, and then, when a dependency is needed, it's created by the container and injected where needed. Now you may be thinking, why is he explaining dependency injection and a dependency injection container here? Well, in the program of our ASP.NET Core application, we should use dependency injection as well. ASP.NET Core comes with a dependency injection container built in, and so we should register all services we want to use at the startup of the application. It is possible to substitute the built-in container with another one, but most often you will use the default, which is very capable and enough for most applications. Okay, so how do we use this baked-in dependency injection then? Here is a snippet of a slightly more extended program. We already saw that the builder, which is of type Web Application Builder, exposes the services collection. To this collection, we can add our own services. As mentioned, ASP.NET Core itself uses this, and the framework comes with many services that we can plug in if we need them in our application. For many of these baked-in services, so framework services, extension methods exist. In this line here, the highlighted one, I'm calling add controllers with views. Controllers, views, that smells like MVC. Indeed, this method will register the most common services part of ASP.NET Core to work in our application. By default, an empty application doesn't know how to do MVC, but adding this line here adds these services and so enables our application to work with these. Next to framework services, also our own classes that we create should be registered with the container. Here's that logger service again. I want to be able to use it using its interface throughout the entire application. We can then use the add_code method to register the logger service using its interface. Once registered, where we now need an instance, we'll get it, inject it. Here's already a controller class, which specifies that it needs an iLogger service. When we have registered the service in our container, the constructor parameter logger service will be instantiated by the container and thus injected. And this is called constructor injection. And all of this works because we have registered our service in the program class, in the service registration part, that is. Registering services was one task of the program. Creating middleware is the second one. When a request is received, it will travel through a set of middleware components, often referred to as the middleware pipeline or the request pipeline. A response will be created and that will be eventually sent back to the browser. In the program.cs, we will set up the middleware pipeline, which consists out of a number of middleware components. And in the end, it's a set of components that will work on the request to create a response. Each component in the pipeline can look at the request, modify it, pass it on to the next component, or generate a response. And when a response is generated, the response will travel through the pipeline as well, in the other direction. And middleware components can also change the response again. ASP.NET Core comes with many built-in components that we can use or we can create our own. At the very end of the pipeline sits endpoint middleware, which is basically going to call the code that generates a response. That will typically invoke our code, which we will write, for example, in ASP.NET Core MVC. This is how you should imagine the middleware request pipeline. All components are placed in a sequence. A request comes in, is inspected by the first middleware component, which can pass it on to the next one, and so on. At the end is endpoint middleware, which will invoke code to generate the response. And that response will then travel in the opposite direction through the pipeline and then back to the browser. Here is a snippet of the program class of a new ASP.NET Core MVC application. We already saw the service registration. This highlighted part here is where the middleware is set up. On the app, we call several methods that start with use XYZ, use HTTPS redirection, use authorization, use static files. All these are methods which plug in middleware. Let us try understanding how such a middleware component works, and I've chosen static file middleware. Remember that we saw earlier that static files should be placed in the www root folder. Now when a request for, say, an image, a JPEG file, is received, it'll at some point encounter the static file middleware, if we have added it to the pipeline, that is. That middleware will see that the request is for a static file, and it knows where to look for that file, so in the www root folder. It will return the file from there as the response, and it will in fact short-circuit the request. The request won't travel further through the pipeline. It is handled by the static file middleware. The endpoint middleware, which could be, for example, ASP.NET Core MVC, won't even know about the request, hence decreasing the load on the server and thus improving performance. One more thing. The order in which we place the components in a pipeline is important. It really is a sequence, and placing the components in a different order can have a different effect. Knowing the exact order and thus deciding which component to place before or behind another component can require some reading of the documentation. So to conclude, registering services with the container and setting up middleware are the two important tasks for the program class in our ASP.NET Core application. All of this may be a bit hard to follow in the beginning, and I do think that is normal. Setting up even the smallest ASP.NET Core application requires that we set up things correctly. Over the coming modules, while we create the application, we will see how to use both functionalities of the program, and things will become clearer. If you're coming from an earlier version of ASP.NET Core, all of this will be very familiar already, although slightly different as well. In previous versions, Microsoft recommended that we had two files, program.cs and startup.cs, and you can see an example here. Setting up the service registration and the middleware pipeline was actually done in Startup, so a separate class. With ASP.NET Core 6, these two files were merged into what now has become the program.cs we have looked at in this module. If you want to keep using the quote-unquote old model, that is absolutely fine, as it will still work and keep on doing so.